All right, the last problem from yesterday. So we're going to have to use the quotient rule here, and I'm going to do a couple of things. I'm going to identify what the functions are. So my top function of my quotient rule is just x squared. The outer function in the denominator, I'm going to write it as something raised to the 1/2 power. And then my inner function is x squared, or x to the 9th plus 9. Okay, that might help us get ourselves a little bit more organized here. All right, so let's apply the quotient rule. We have to take the low function times the derivative of the high function. So low function is that thing raised to the 1/2 power times the derivative of the high function. Well, that's just 2x. And then from that, we're going to subtract the top function, the high function, I guess we're calling it that, times the derivative of the bottom function or the low function. So the derivative of something raised to the 1/2 power, we know is going to be 1/2 times that thing raised to the negative 1/2 power. And then the inner function there is x to the 9th plus 9. So the derivative of that is just 9x to the 8th. So we'll do the outer function, the derivative of the outer function. Okay, that's x to the 9th plus 9 times the derivative of the inner function. And then all of that is over the low function squared. So we have x to the 9th plus 9 raised to the 1/2 power, and then all of that squared. Okay, now that's just the derivative. We've got a lot of work to do to simplify this, so let's go through this kind of one piece at a time. The top part, we can just rewrite as 2x times x to the 9th plus 9 raised to the 1/2 power. And then here we have, so we have 9x to the 8th times 1/2 times x squared. So that's going to be, 9/2 times x to the 10th power. All right, and then we have x to the 9th plus 9 to the negative 1/2 power. Now, this denominator, I'm going to split up and make two fractions, but I'm just going to figure out what that simplifies to be. So just like we saw in a previous example, the power of 1/2 raised to the power of 2, we multiply those together and we just get 1. So if I split this up, I could make it x to the 9th plus 9 and x to the 9th plus 9. And those will each be raised to the first power. And then this is similar to what we had to do, I think, in problem number 2. So let's rewrite each fraction as much as we can. So we have really the second fraction I want to kind of talk a little bit about here. We have minus 9/2 x to the 10th. And then I can move that x to the 9th plus 9 to the negative 1/2 power to the denominator. And then just like we saw in another example, this is raised to the first power and then raised to the 1/2 power. We're going to add those exponents together. So just to give myself a little bit of space here to work, I'm going to write what that would be if I added those exponents together. So it'll be x to the 9th plus 9 to the 3/2 power. So what I have in the first fraction, we can't really do a whole lot with that, but I want to be able to try to add these two fractions together. Now, before I do that, I want to address this. So that negative 9/2 could be rewritten as 9/2, like actually taking that negative 9/2 and writing it as negative 9/2. And it means exactly the same thing, and that way we don't have any fractions in fractions. All right, so now I've got it set up so that I can go ahead and begin trying to add these two fractions together. So what I need are common denominators. I need to have x to the 9th plus 9 raised to the 3/2 power. And to achieve that, I'm going to have to multiply by x to the 9th plus 9 to the 1/2 power as a giant 1. I also have this 2, so I'm going to multiply the top and bottom of my fraction by 2. And once I do that, I now have the same denominator. So let's go ahead and simplify what we have just a little bit more here. So y prime equals, so 2 times 2x, that's 4x. When I multiply this part together, I'm going to add those exponents together and I get an exponent of 1. So I'm going to have x to the 9th plus 9 to the 1st power. And then I'm going to subtract 9x to the 10th power. And then I've got my common denominator, which is 2 times x to the 9th plus 9 raised to the 3/2 power. And now it's just a matter of doing some really simple algebra and combining like terms in the numerator as much as possible. So I'm going to distribute the 4x to the 10th plus 36x minus 9x to the 10th all over 2 times x to the 9th plus 9 raised to the 3/2 power. All right, so let's combine like terms. We have 4x to the 10th. So let's see, we have 36x minus 5x to the 10th all over 2 times x to the 9th plus 9 to the 3/2 power. And then just like we saw in the last example, you know, we could factor out an x from both terms in the numerator and make that 36 minus 5x to the 9th. And then you could also, if you wanted to, you could write that as the square root of x to the 9th plus 9 raised to the 3rd power. And any combination of these two answers would be fine. So whatever you like, this one or this one. And then as far as how you simplify the numerator, I don't care as well. All right, hopefully that helps. Watch the video for today, and then I'll see you on Monday.